Last week, we worked with translations of functions, and this week, we're working with dilations. So last week, when we were translating functions, we were shifting linear functions straight up or straight down. So if we were translating this line up, it would go in this direction. All the points would just go up by the same amount, or all of the points would go down by the same amount. But the points would move the same number of steps up or the same number of steps down. Now this week we're going to be working with dilations of functions. So we're still going to be dealing with linear functions, but let's see what happens when we dilate the functions instead of translating the functions. So first of all, there is a small typo or an error on your paper in your book. On page 227, you'll want to go right here and change this from P to A. So on this table, this right here should say A of X, not P of X. All right, so let's get started. What we're going to do first is we're still starting with the function f of x equals x. And remember, what that means is the output, when you put in an x, is going to be the same as x. So if you put in a -2, you're going to get out a -2. If you put in a 0, you're going to get out a 0. If you put in a 2, you're going to get a 2 out. So what we're going to do now is we're going to change f of x. So we're going to take this function, f of x, and we're going to change it by a factor of 4. Now what this means is we're going to take the output and multiply by 4. So as before, our input values are going to stay the same. See? Our input is staying the same. And our output is going to be what gets multiplied by 4. So we're going to change by a factor of 4 to create this new function called a of x. So take your output and multiply times 4. This times 4. This times 4. And all of the other variable values in between. Times 4, times 4, times 4. And then put those here. What you're going to do then is you're going to sketch that graph. So for each of these points that you make, you're going to plot that point on the graph. This is point -2, -8. So I'm going to go to -2 on the x-axis, and then I'm going to go down to -8 and put a point. I'm going to go to 2 on the x-axis, and I'm going to go up to 8. So 2 up to 8. And you can plot your other points too to make sure that they fall on the same line, but take your straight edge or the edge of your protractor and draw this line a of x. And I'm also going to label it right here. So that is your line a of x. So now you're also going to identify the slope and the y-intercept of this new function, and you're going to write the equation in general form. And general form is you put the name of the function and then you're going to put in the slope, and then your variable, and then you're going to put your y-intercept. So if I look up here, I'm going to use these 2 points that I just graphed. My rise between these 2 points is 16 because I'm going from -8 up to +8. So my rise is 16. And then I went from this x, which is 2, -2, to 2. So that is 4. And then I see that my line, if I start on the left, if I trace it, it goes uphill. So I know that my slope is positive. So I can simplify this to find out my slope is 4. So my slope goes here. My y-intercept goes here. I look at my graph. I see that my graph is going through the y-axis at 0. So that's my y-intercept. Once you have this equation written, if you want to simplify it, you can, because remember, this is 0, so we don't really need +0 on the end. You can leave that +0 off.